Hello. Got 1 minute? But as people are walking in, I want you to do one thing for me real quick. Turn around and look at the back of the room. In the back of the room, we have our AV crew, and that's a tough job. They're making this happen, and I've done many hours in live events, and it's tough because when you make a mistake, an entire room of people see it or hear it, right? And so you have hours of boredom followed by seconds of terror. And so anyway, we appreciate what you guys are doing for us. Thank you very much. So I'm here to talk about using Clojure for live sports television and really live sports production. This doesn't always go out over the airwaves. Sometimes it goes to a stream. Sometimes it's in a venue, right? But my hope is by the end of this talk, you're gonna have an idea of what's involved in pulling off a live sports production, and then how to build a system using Clojure that is low latency and reliable and really doesn't go down or lose data. And then why Clojure in particular, I believe is just a great language for this domain. And so those are some of the goals of my talk as we go in. But before we talk too much about Clojure, let me mention who I am. So I'm Christoph Neumann. I'm a software engineer and founder. I have a consultancy called AppSauce, and we make custom software for live sports production, among other things. And I created a product that's used for situations like this, when you need a remote presenter to a live audience, or you need to bring a guest into a TV show, and that product is called Hypersignal. All of that uses Clojure, all the way up until we have to call the APIs in the browser and things like that. I also am a podcaster. I have a podcast, Functional Design and Clojure, with my good friend Nate Jones. We started this a number of years back, and we go through furious spurts of episode creation and then take some breaks. And so feel free to check that out too. So I want to take you back to December of 2015. Maybe it's not memorable for you, but it's memorable for me. And in December of 2015, I'm sitting there trying to make a hard choice. I'm really excited, but I'm really afraid. That choice is, do I commit and use Clojure for my next project? I'd been dabbling with Clojure for a while, and I was getting more and more excited about it, but the stakes seemed really high, and I just wasn't so sure this would be a great idea. The project was for Heroes of the Storm, and I needed to create a tool for that competition. As part of the game, teams take turns picking from the myriad of heroes that exist in that game, and they have to pick which heroes they're gonna have on their team. And in order to make this fair and competitive, they each take turns picking a hero, and that's called drafting. And I needed to make a draft tool that the teams were gonna use live on air for the competition, and it needed to be real time. And so the teams would get together in a huddle, and there you have the production assistant there, the tournament assistant helping, and they pick a hero, and then they lock that hero in, and boom, that hero goes up on the big screen. That hero drops in this big LED panel behind the team. There's a lighting effect, there's a sound effect, there's all this stuff that happens when they pick a hero. And then you have commentators, right? You have casters and analysts, and they see which hero got picked, and they go, ooh, that was unexpected. Why did they pick that hero? Well, that's interesting. And then they begin to talk about what it means. And so you have a room full of people. You have this tool that's being used as part of the competition. You have it being analyzed to death, all these effects. And so I'm thinking to myself, oh man, I really don't want to screw this up, right? Because that mistake is going to be seen by everybody there. But actually, it was a little worse because this was going to be on ESPN2. And so this mistake, not only was it going to be seen by everyone in the room, whatever screw up I had was going to be seen by everybody watching the live stream and by everybody watching the event on national television. So I was thinking to myself, I really want to do this. This is a great idea. This is a terrible idea. What am I thinking? This is a terrible idea. How can I use this Lisp, crazy Lisp language? But oh man, Clojure is such a great language. And I'm having a battle between my brain and my heart on should I use Clojure for this? To give you a little bit of background on why this was so hard for me is I was a PhD student in programming languages. And I had gotten the full indoctrination of type systems and object-oriented programming. One of my advisors literally wrote the book on object-oriented programming, Timothy Budd, and he was a researcher in Smalltalk. One of my other advisors, Martin Ervig, had fundamental contributions to functional programming and representing trees in a type-safe way. And so I thought multi-paradigm programming is it. It's got everything. It's got all the features. It's the best of everything. And you know what? Let's add some static typing in there to make it even better. And so I was in academia for a while, and I was enjoying that. But after a while, I got burned out on academia and realized I loved industry better. And I had gotten my master's degree, so I went back into industry, and I worked on this behemoth. I went to Hewlett-Packard and worked on an enormous printer that over the years got even more enormous. This thing can print 10 feet per second and up to 10 feet wide, right? So you're literally printing 100 square feet, double-sided, every second. And this is a machine that when something goes wrong, it can cost a lot of money, it can break things, or it can hurt people. And so while I was working in manufacturing, I was realizing, oh man, I really don't want to screw this up, right? I don't want to cost money. I don't want to hurt people for sure. And so I learned a lot about making reliable systems when I was in manufacturing. And so I felt comfortable in high-stakes environments where reliability was key. And I knew when I went to HP, I brought all that multi-paradigm, statically typed programming with me, and I introduced Scala to the team, and I felt really good about how it was helping us make reliable software. But after I'd been at HP for a while, working in manufacturing, I decided I wanted to go work on fresh new businesses, and I got involved in startups again. Well, in startups, I ran into a different problem. I needed to make stuff, and I needed to make it fast and also be reliable at the same time. And so I was feeling this friction from my language choices, my tooling. And I was like, how can I make things fast but have it be reliable? Right? I was experimenting with more dynamic languages. I was using Groovy. I said, let's just go all in on JavaScript for a while. But then I ran into what felt like a catch-22. If I'm fast now, I run into a mess later, and that really hurts reliability. If I'm very careful and very slow now, well, I'm going to have reliability later if I'm still in business, right? So you only got so much runway. So that was pretty rough. But then, meanwhile, during this time, I noticed that my thinking and my methods for software development had been changing, but not my programming languages, right? I'm using the same tools I had used in grad school and beyond to solve this. However, there was this one language that kept catching my eye. I bet you can't guess what that language was. So this is my Clojure Slowman. So I actually became aware of Clojure 2008, very, very shortly after it was released. And you know what I thought? Is this a joke? Is this for real? What kind of Lisp fanatic would make such a thing? Right? And then I'm like, oh, I bet this is one of those like hobby languages, one of those esoteric languages, like the white space language, right? Or the chef language where every program is a recipe, or golf script where you're minimal characters. But that crazy language didn't seem to go away. And in 2011, I watched Simple Made Easy, and I thought, well, this guy doesn't sound crazy. He doesn't really sound like a fanatic, except maybe for simplicity and practicality. And, you know, he's really not all that esoteric, except for maybe those Latin definitions are a little esoteric. but all the rest was intensely practical. And so I thought I have to give this a try. So over the next couple of years, I was having fun, playing around with Clojure, but I wasn't really ready to commit. And so that brings us back to December of 2015. I was facing this new project, and boom, something happened. Does anybody remember a special thing that happened in December of 2015? Probably not. Advent of Code was released, right? And the community went crazy. And what was cool in the Clojure community, there was all these people sharing their solutions, right? They're checking them into GitHub, they're sharing solutions, people are doing this as a new thing. It was so much fun. And this happened right around the same time that I was considering starting this new project. And so I'm thinking about how I want to approach this new project, and I'm coding up the latest problems of the day, and I'm thinking about how I want to solve this, and I'm coding up the latest problems of the day. And so maybe it was the dopamine from all those solutions that I came up with, or maybe it was just the intensity of the activity. But I thought, yes, I am going to use Clojure after all. And what's the worst that can happen? And so it turned out to actually be a pretty good idea. There was a whole brain flip that I had to go through, and so that had me really scared for a while. But then it continued to change my perspective on programming, and it very much aligned with the perspective that had already been changing. And I continued to use it on a number of projects, so the Heroes of the Storm project, but then also scraping Twitch for the top channels and creating a visualization of that live for some of my clients. Enabling the not-so-secret debug log for Hearthstone, and slurping in those the debug lines dynamically, and parsing those with Instaparse, and creating a representation of the game state, and then using that live on air. Developing custom integrations with the Overwatch server team and helping launch the Overwatch League. Also, doing that again for Call of Duty, working on custom integrations with the Call of Duty server team, and helping reboot the esports for Call of Duty and launching the Call of Duty League. And then that led into working with other large equipment providers, brands like Wimbledon and brands like the NFL. And so over time, I've been able to use Clojure in a big way in all of these environments. And so from that experience, I can tell you that Clojure loves live sports production. It's a great fit. But why? Why is it a great fit? Well, first, you need to understand a little bit about live sports production. So who here has done production at all? Maybe theater or something like that, production at all. Okay. Who here has done TV production or AV production? Okay. So, a fraction of the room. So in production, it's all about capturing, creating, and broadcasting. So we want to capture audio, visual data. We want to put all that together into a big live soup of information and video and audio and experience, and then we want to send that out to screens and streams and the national airwaves. So we have all kinds of equipment involved in this, right? We're pulling in video and mics, so we got microphones and cameras, and we're going behind the scenes, and we're getting little featurettes, once again, of audio and video of that. And we're taking in all these sources. There's so many sources. This is a control room. You can see all these sources coming in live, and you have stuff that's recorded that you're going to play out later, and things like that. And we even want to get the gameplay itself. And so we're capturing the gameplay, and we're capturing the audience, and we're capturing all this stuff. But data is everywhere. So let's take a look at this screenshot of part of the Call of Duty live stream. So you see data, lots of data. We have the score. Well, that's data. We have the clock. That's data. Well, we have the map we're on. That's also data. We have the team names. That's data. We have the side the team is on. That's also data, right? You have to keep track of that. We have the match score. Well, that's data, and that's from a totally different place. It's not even from the game. It's from some tournament system. We have what this match means. This is a championship match, so that's some context. Well, that's data too. We have the players. We have the order they're sitting in. We have to match the players up to the seats because we have cameras on all the players. And so we need to know when we press, button 3, which player that's going to be. We also have their jersey numbers and more information about that. We have whether they're alive or dead or have special powers in the game. And we even have a feed of notable events that have occurred. So you can see even in this one screenshot that didn't seem like much when we first put it on, there's data everywhere, right? And then that isn't even counting all of the gameplay statistics. So this is from Overwatch, and this is only a fraction of the performance statistics that are available in the game. This is an example of a live user interface that's used by the casters and the analysts to see insights into the game as it's played. So all of those sources come together to create a story. We're taking the video, we're taking the game, we're taking the data, we're putting it all together, and we're telling a story of what you're seeing and why it matters. And the talent, or the casters and the commentators, they're telling that story. And it's a team effort. And so we take those audio and video sources, we bring them all together, we throw some data on top, and we tell this story, and we create this experience. Whether you're in the venue and you're seeing things on the big screen, or you're outside and you're watching the broadcast. We're weaving a story of what you're seeing and why it matters using all that. And it is a live act of production. It's gonna happen whether you make a mistake or not. It's gonna happen even if something crashes or goes down. You're gonna have to do it, and you're gonna have to keep going. And it can get really, really big. And really, really complex. And so live production is really hard, right? You have a lot of people and moving parts. You often need to improvise and flex because you don't get to postpone when it was going to happen. You need to do it anyway. So you need to make do with what you have. You need to make it happen. And success is expected. People get irritated or annoyed when things go wrong. But your mistakes are recorded and watched by millions. The bigger the game, the more complex the production, but the more complex the production, the higher the chance of something going wrong, right? Sounds great, right? To give you an idea of how crazy this can be, I got to know an Olympics tech manager who worked in Sochi. And all these trucks come from all over the world in order to make this production. And some of those trucks are from the US. And it turns out the US uses a different voltage than many of the rest of the world. We're on 110 volts, right? So they needed to adapt the power for these trucks in order for these trucks to be able to run. And so in the spirit of live production, somebody had a great idea. Let's take a UPS, an uninterruptible power supply, those things with lots of batteries that keep things on when the power goes out, and let's take all the batteries out of it. And let's just plug it into power, and it will give us 110 coming out, and we're just gonna use it to downstep the power, and that's gonna be just fine. And it was a great idea. It worked perfectly. UPS without batteries, who would have thought? Until it got to about 110% of its capacity. And so it was a little overloaded. And then the day got really hot. It got up into the 90s Fahrenheit, or 30s for you Celsius people. And the production manager was walking by. He looked over at this UPS power adapter shim device, and he noticed something was different. There was a flame coming out of the side of it. Well, that's not good. So he did what any of us would do. He ran and grabbed a fire extinguisher, and he put out the flame. But then he got some help, and they posted somebody to stand there and to continue to put out the flame until they could figure out another way to get power to the truck, because they weren't gonna be turning the power off anytime soon. And that captures the spirit of live production. You're gonna figure out a way to make it happen, and then when that goes wrong, you're gonna figure out another way to keep making it happen. So this is really different than your 24/7 SaaS application, right? A little bit different context. Live production is kind of like manufacturing, but you're building the whole factory in a couple of days, but you're still expecting perfection. And then you're gonna tear it all down and move on after the event. So it has some pretty brutal demands working, right? You have these immovable deadlines. You have all these parts that aren't there all at the same time until the last minute. And so you're working in these incomplete environments, or maybe something did go wrong and part of that's missing. You have all this integration. There's so much gear involved, right? And you need to keep everything up and running. And then it all needs to work right now. You can't go, hey, hold on. Let's give it 10 minutes and try again, right? The show must go on. And of course, there's mountains of data, especially in esports. I've worked in both traditional sports and esports, but esports has the most data. And then you need to save everything. You need to write it all down. You need to capture it because that is the record. So in this critical period of time, this 2-hour or 4-hour window, you need to record everything and lose nothing because you don't get to do it again. So that leads to a certain amount of stress, as you imagine. So I know what you're thinking. After seeing those kind of working conditions, where can I sign up? I think it takes a certain kind of person. You either look at that and go, yes, or you look at that and go, no thanks. And so we pull this off with a combination of language and architecture. You could say, sure, the architecture is the most vital, but the architecture creates the groundwork for success. Without the architecture, you're no matter how good or helpful your language is, you're still going to be in trouble. But the language actually helps you pull this off. And so what are some of the implications? So when we have immovable deadlines, we need not done to work anyway, right? We need things that aren't there yet or things that went down to be okay. We need to handle those missing parts. We have all kinds of things we got to integrate, so we need to develop those integrations quickly and easily. And we need to make sure that all these things are decomplected and isolated and redundant, so there isn't the linchpin that brings it all down. And because it has to respond now, we need it to be live and multi-threaded and lock-free and all that. And because we have mountains of data, we really want just working with the raw data and working with generic data to be productive and useful. We want it to be first class. And we need to be able to save everything, so we need to be able to take all that raw data and write it down too in an easy way. And because of stress, it has to be simple. Because the last thing you need is to try to figure out some really complex thing when everything seems like it's falling apart. And so Clojure, as we'll get into, is helpful for all of these. In terms of reliability for this system, I just want to address this briefly before we move on, because I'm going to focus more, even though the architecture is essential, more on the language aspects and the architecture within Clojure. But for reliability, we use redundancy and clustering, right? We use idempotency so we can retry things over and over, because when something's not there, you want to be able to try it again later. And if it just happened to come up and you do it a couple of times, you don't want to mess things up. We use a technique called reconciliation, where we have a record of how something should be, a record of the way it is, and then we use reconciliation to figure out what we're supposed to do to make it be the way it's supposed to be. And then we use co-location because we don't want to lose data. So if we can run that thing on the game server or directly next to it, that's great, because if it has to reach across the Pacific Ocean to make it into the Kafka queue, well, you could have a problem if you have an internet route that goes down. And then we use stream replication because we want to get that data as close to the point of use as possible. And so we're going to capture that data as close to the point of origin, and we're going to replicate it as close to the point of use. So those are some general principles that we use throughout this system. I'd be happy to talk about this more at great length, but just to kind of lay the groundwork for reliability. There's so many integrations. So these are just the ones I could think of when I was typing this slide off the top of my head. There's even more. But you have the game, you have the software running the tournament, you have graphic systems that for the on-air show, graphic systems for in the room, screens, lighting, sports information systems that have all the details, biographical information, team history, factoids, things like that. You have storage for data, storage for media. You have data warehouses. You have a whole operational infrastructure and monitoring and all that. You need to handle identity and authentication because not everybody should have permissions to everything else because you don't want just anybody to be able to take the whole thing down. And you have all these things that are foisted on you by sponsors and other valued partners that have requirements on your system. And so, for example, here's an example of a sports information system. It's giving us the current standings in the tournament. Or we're going to take some of that data and we're going to make a graphic. Like this comes from the Overwatch League, and we're going to use this graphic to tell a story. So we need to know what happened in the past because remember, we saved everything. And we can look at how these teams did before, and now they're going to be on this map again and how we might expect them to behave. Or we're going to create, like I showed you before, a live visualization that shows you all this information and get the data out of the game. We can't make this if we're not integrated with a game. And a lot of these, not all of them, but many of them, are 100% custom integrations. For example, I worked with a game that shall remain nameless that had one of its versions ran on a specific console platform. And we needed to get data out of that game for tournaments. And of course, the developers are paranoid that they don't want anyone else to be able to do this. So they have a secret port, UDP port, that you have to send a special cryptographic message to after you go through this special song and dance to even be in the right game mode, to even make this happen at all. And then if you get that far and get the encrypted data passing back and forth, it's a in-house serialization protocol that you have never heard of, right, to actually pass the data back and forth. And so we need to integrate with that, and we need to make it work perfectly in production. So this is a simplified system diagram of some of these integrations, right? So on the left, we have these systems that we're integrated with, like the game server, the tournament system, the sports information system, for the purposes of this example. But now imagine about a dozen or two of those. And then let's have an app for controlling different systems, and we'll have another app for authoring graphics. These are two very common things that need to happen. And then this live data engine, which we'll look at more on the next slide, is going to take all these sources and take the input from the user, and it's going to produce outputs to the integrations that go to live visualizations or broadcast graphics for on-the-air graphics or stage graphics for big LED walls or screens or things like that. So the way this live data engine works is this is sort of the logical structure of it, right? The way we implemented it was with core async, and we set up this graph of what we called workers, which are little core async things. They maintain a state. You could kind of think of them like how a transducer maintains a state, but in this case, these workers have to be able to do I/O. So they have a thread, so they have a local state and a thread, and they're kind of in this recursing forever situation. And so we integrate these sources via some API. So we have a special kind of worker, which is a collector, and that worker is gonna reach out via the API. It's gonna pull in some cases, it's gonna do this custom protocol in some cases, it's going to be reading the file system in some cases, and so on and so forth. And that collector is going to produce a Clojure data document that describes all the things that matter for that problem domain, right? And we're going to have one collector for each of these integrations. And then we're going to have another kind of worker that we call an asynchronous join worker that's going to hear these records, well, these documents, these big data documents, and some of these can be huge, right? We had one, the Overwatch game state, it's like 250K per snapshot or something. It was a huge amount of data. And it's going to take different data sources and it's going to pivot them and merge them and join them and produce a view of that data. And that view is very specific to the needs of the outward integration. And so this is nice. You have this kind of data mart, right, where you have things represented in the origin domain on the left. And then you have things represented in the output domain on the right. And then core async allows us to do all of this data flow instantly and concurrently. And so as things change, these async join workers, they get a copy of all the current states of everything, and they rerun their pure models. And so we refactored everything. Well, we factored everything, really. We didn't refactor it. We factored everything so that all of the work is structured in terms of a pure model. And so let's take a look at this. So here's an example data flow. So the game integration might tell us what players are in the game, and it might tell us what the player stats are. The tournament system integration is going to tell us which teams are playing right now in the tournament, because the game might just tell us red team and blue team. Well, who's the red team? Who's the blue team, right? We need to know what actual teams they are. And it's going to tell us what the match score is, because the game has no idea about a match, right? It just knows about that current game. And then we have the sports information that's going to tell us players' hometowns and jersey numbers and things like that, and team colors and team logos and things like that, right? And so then those are going to come in, and we're going to have a view, a live stats view. And that live stats view is going to be made by one of those async join workers. And it's going to take, in this case, the players in the game and their stats, and then some of their details, because maybe we want to put jersey numbers on it. And it's going to make that document, and it's going to send it to a live stats application that I showed you earlier, or the stage graphics, or the broadcast graphics. And then we have the tournament, then we have the match state coming from the tournament system, and then some of the details, and it's just going to send it to the broadcast stats, because we don't care about that in the venue, right? So you see that the way that it's a very data flow oriented thing. And so this is great in Clojure, because Clojure is a great fit, because Clojure is data oriented, right? Data is central. When we look at this diagram, data is central to everything, right? Data is easy to understand, visualize, and save, right? The information isn't trapped in the apparatus of the language, right? Sure, Clojure has language constructs for representing those data, but it's very easy to represent and transform into things we can visualize. Behavior has been separated out, right? So therefore, the information is central, not the behavior. And so this encourages us to put everything into the data that we can. Everything that matters is in the data. And because we have immutability, Clojure is safe. So we don't have to worry about things messing up our precious data. When I grab that data from the Overwatch server and I'm holding it in memory, I can know nothing can corrupt that, right? And it can get written down in a safe way, it can get transformed in a safe way, and I can do that concurrently and cheaply because it's shared in memory. And this really helps make isolation and redundancy easy, because all these different transforms are separated from each other. If we do have a bug, well, it's not going to take down all the rest of them if it's downstream in that join. And Clojure's responsive, because we have this built-in concurrency with core async, right? And lock-free concurrency with atoms. So we can use this information quickly and get an answer back out right away. And lazy evaluation helps too, because we don't want to do any extra work unless we need it. So a story, when I did integrate with the Overwatch server, I went into their office and I worked with their server team. And we weren't 100% sure what data to export out of the game, because there's so much data in the game. So we went through this back and forth process of, well, what should we export and what should we not? And so it's exploratory. So we had a discussion what we needed, and then the server dev went and he spent a little bit of time in his code and he kicked off the compile. Meanwhile, I was setting up my Clojure environment, getting it all, starting a polling loop to the JSON endpoint to the IP on the network. And he would come back and he'd be like, okay, I got the compile, it's up and working, it'd be great. From the REPL, I'd run it, I'd go, great, I got the data. And we looked at the data there in the output, and I'd go, okay, let's oh, can you add this? He'd go, sure, no problem. So he'd go back, he'd spend some more time, he'd kick off a compile. 20 minutes later, he'd come back, okay, I put it in there. I said, I noticed you put it in there because I was already pulling the data, writing the data, capturing it, and saving the data that whole time, right? And so we went through this process where 20 minutes of compile, we come back, 2 seconds of reppling. Yep, it works. 20 minutes of compile, but then we got the whole integration saved. And then I had this idea like, oh, what happens when I leave and I don't just have an Overwatch server at my disposal or a server dev? I thought, well, I better save all this data. So I very easily was able to serialize, this was all in Eden, and just concatenate Eden to a file. And then later, and timestamp it all. And then later I was able to read that in with the timestamp and play it back at the correct time with the correct timing information. So now my collector, if we go back to that diagram, that collector I replaced with something I called a faker that gave me the same input into the data flow, but it came from a file instead of coming from an actual Overwatch server, and nothing else in that pipeline needed to care. And this gets back to Clojure is live and interactive, right? This REPL connected editor cycle gets rid of the whole compile run, right? Any complete expression is something you can run. It's an entry point. You're working with the actual thing too. You're reaching into the actual system and working with it right now. You can get the state of it right now. You're not working just simply with a representation of it, but you can call it and get the data. And that allows you to experiment and discover what you need to do. And you can manipulate your source very efficiently and safely using structural editing. And also, because this data is incomplete, Clojure treats incomplete and partial as first class, right? These integrations, sometimes I just want a little bit of it. I don't want this huge giant specification, or it's totally custom. And so it's very easy in Clojure to work with part of the data or part of the API. I don't need to generate a bunch of bindings, or not bindings, but I don't need to generate a bunch of handles and classes and stuff for an API. All these parts I don't want to use, right? And so generic data, so using part of it as first class, generic data is first class. I can work on just a little part of it and get it working before I have to get it all working. And so another example is in this is an earlier version of that live visualization, and this came out of having conversations with the commentators. And so the commentators sit there and they look at the screen, and they're watching the game on the left, and they're looking at the screen on the right, and they want to say something insightful. And so they told me information they would like to be able to know that wasn't in the game itself. And so I took the recordings of my sessions for the integration, and I use that to play it back and develop a UI to visualize it. Then when we got together on site at the big event at BlizzCon, they said, oh, this is missing. Oh, that is missing. No problem. I had them come, sit down with me, and I had my recordings of the data, and through interactive development, added more and more things for them to see, and they're like, that's it, I love it, that's great, let's use it. And we did. A few hours later, we were using it live in production. Right? And so Clojure really gives you this phenomenon of being able to grow things and start small. The language foists almost nothing on you itself. It's very simple, right? It has few constructs, but also few demands. You can start with an expression, you can grow some expressions and turn them into a function, you can build those up into composable functions, you can stitch those together with Clojure Core, and then you can add schemas later when they're helpful, right? And so Clojure, by building this up, that's the way it happens. Clojure builds this up, allows me to build this up. And the same thing for lighting. We integrated with a lighting system, had to sit down with the lighting board and work that out. And from the REPL, once again, the lighting guys say, oh, send me this MIDI cue, send me that MIDI cue, send them the MIDI cue. And we would experiment to see what works in this space, that giant lighting ring up there. We're manipulating it live to figure out what works based on what's happening in the game. And so you end up with this meta tool for Clojure. You have Clojure itself, you have the REPL, you have your editor, and you have some data visualization, like a data browser, like Portal earlier, right? And through this, you can eliminate all kinds of tools, right? Everything is staying in the Clojure universe. You can evaluate expressions to explore and visualize. You can grow that up into your actual application, right? And it's all just Clojure source. And Clojure is robust, right? Because it's safe, because you are working on the actual thing, you're not just messing around with your representation, but you're interacting with the actual world. Because Clojure has a good story on time and behavior and identity and separating those, you end up with this robustness in working with Clojure. And then when the stress happens, you have Clojure is simple, right? Fewer language constructs, fewer demands, less hoops you have to jump through. No side effects. Way easier to think about when you've been working for 16 hours and you're really tired, right? By separating time, state, and behavior, you don't have to hold all that in your head, so it's a low cognitive load. The problem is central, not the language demands, right? Not all the ceremony that you have to go through. So Clojure really does love live production. And the more I've worked with this, the more I go, well, you know, what else needs to be reliable and grow quickly? What else really, we want to keep things minimal for the long run. What else do we need to be safe and responsive and interactive? Well, I think Clojure loves startups too, right? Because all of these requirements, if you think about it, well, they're also true for startups. And well, you know what? They're also true for prototypes. Because you don't really know where you're going with prototypes either, and you have to figure it out. It's a new integration, and sometimes you have crazy unrealistic deadlines that don't get to move, and you have to make something that works. So maybe it's not just that Clojure loves live production or startups or prototypes. Maybe Clojure just really loves the messy real world. As Rich calls it, situated programming, right? Clojure isn't here to make the world conform to its image, but it's here to help you work with the real world. And so I have a mission. I have a personal mission. I want to continue to take Clojure outside the Clojure community. I want developers to learn about how Clojure loves the messy real world. And I want them to be able to make bulletproof software that's fun to maintain instead of a schlep, a grind, right? I personally have been through programmer burnout, and I wish that on no one. And I would love, I've talked to so many of you, and I have heard your Clojure story that many of which involve burnout. So are you interested in that too? If you are interested in that too, then let's talk. I would love to talk to you afterward. And I hope in this talk you've had a chance to learn about live production, learn about how Clojure is very much suited for that and other things in the real world, and how we were able to do a really robust real-time information system with no data loss and no downtime. Thank you.